everyone, I'm Anthony from Niner Bravo Aviation. Welcome to the E6B Whizwheel course. You're going to learn a lot about what the E6B is, how it's laid out, and we're going to cover multiple examples on how you can do sample problems. At the end of the course, there's going to be a quiz where you can test out your mastery of the E6B skills with some sample questions from the FAA written, or like the FAA written questions anyways. So let's start out by looking at the construction of the E6B. Now, at first glance, you can tell that one side is a circular slide rule with a lot of numbers and things that often intimidate, but I'm going to show you that there's no reason for you to even feel remotely scared of this little gadget. It's got the slide rule side, and then it's also got a wind correction side, which you can use also for doing your nav logs and stuff like that. And we'll cover how to use both sides, starting with the slide rule side. But first, let's take a look at the different scales that are on the front of the little E6B here. So when we first look at the E6B slide rule side, we can see there's an inner scale, which is rotatable, and an outer scale, which is stationary. Let's start by rotating the 10s, one on the inner scale, to match the one on the outer scale. So the 10 should be on top of the 10. It should be two black boxes with 10s inside them on top of each other. Once you've got that all matched up, you can see that all of the numbers on the outside of the E6B match the numbers on the inside scale of the E6B. So the ratio here is 1:1. When you're reading these numbers, you can see that the 10, it could either be a 1 or a 10 or a 100 or a 1000 or a 0.1. Either way you look at it, the numbers are always going to match, so the 11 would be the 1.1 or a 110. The 12 would be either 12 and 12 or 1.2 and 1.2, so on and so forth. In between each of these numbers are little tick marks called calibration. Between the 10 and the 15, each calibration is equal to 0.1. Between the 15 and the 30, each marking is worth 0.2. Between the 30 and the 60, each marking is worth 0.5, and between the 60 and the 10, each marking is equal to 1. So earlier I said that we can use the E6B slide rule to set up ratios, and the current way we have it set up shows us a ratio of 1:1. Every number is right on top of the exact same number. Let's change that to a ratio of 2:1. So on the E6B, you're going to want to find the inner scale and look for the number 60. It's surrounded by a big black box that says rate, and it should have a black triangle on top of it. The next step you're going to take is to move that black triangle to where it is underneath the 12 on the outer scale. The next thing you'll notice is that automatically the inner scale is 2 times less than the outer scale. So if you look at the 10, underneath it is a 5, so 5 is half of 10, 5.5 is half of 11, 6 is half of 12, so on and so forth. The calibration of the inner scale gives us a little bit extra information just for grins and giggles here. If we find the 70 on the shiny side of the inner scale, you can see it right there, you'll notice that it's right above a 1 hour and 10 minute marking on a blue ring, which is on the inner side of the inside scale there. As all of us mathematicians know, an hour and 10 minutes just happens to be 70 minutes. You can continue that on. An hour and 20 minutes is 80 minutes. Hour 30, hour and a half is 90 minutes. In fact, if you want to know what 9 hours is, you can look just on the left side of that 60 marking, and you'll find that it's about 540 minutes. You can do the math, but the E6B, it knows the answer. So there you have it. So that's the inner and outer scales and kind of a brief introduction on how you use them. There are some other features on the slide rule side. If you look on the inner scale, which you can slide around, you'll see a couple of windows. One says pressure altitude in thousands of feet, and then it points to 2 different areas there. Later on in the course, we'll be using those to correct for colder than standard temperature to find out what your true altitude is, and also to find out what the density altitude is and what your true airspeed is. On the little slidey guy on the back here, there is a ruler on mine. A lot of other ones have that as well. And most of these also come with some directions of some kind. So on the face of the E6B here, it tells you how to make altitude corrections, airspeed corrections, and do different ground speed checks and fuel burn checks, which we will, of course, go over in the other lessons. You've got flight plan information on here. It tells you all the information you need to take and put on your FAA flight plan. It's got your equipment suffix, so if ATC asks you what equipment is on board, it'll tell you if you're a slant golf, Foxtrot Echo, so on and so forth. On the bottom side of it, you can see that there is the crosswind graph and also a crosswind correction table, which is pretty useful if you want to know all of a sudden what the reported winds are. If any part of it's a crosswind and you want to know what the component is, then it's right there for you in the table. We'll go over how to use that in other lessons. Anyways, that's a brief introduction on how to read the E6B. Let's jump into how we can use it to calculate time, speed, and distance problems.